am Marivine C. Makabudbod, and these are my teammates,
Weni Anu, and I'm Hermione Lolo.
and today we will talk about the mathematics in the 18th and 19th century. In 18th century, mathematics is already a modern science. Mathematics begins to develop very fast because of introducing it to schools. Therefore, everyone had the chance to learn the basic learnings of mathematics. There are many new ideas, solutions to old mathematical problems, researches, which lead to creating new field of mathematics. Lastly, old fields of mathematics are also expanding. One of the famous mathematicians in 18th century is Leonard Paul Euler. Leonard was a Swiss mathematician. Johann Bernoulli made the biggest influence on Leonard. On 1727, he went to St. Petersburg where he worked in the mathematics department and became the head of his department on 1731. In 1741, he went to Berlin and worked in Berlin for 25 years, and after that, he returned in St. Petersburg, where he spent the rest of his life. Euler worked in almost all areas of mathematics: geometry, calculus, trigonometry, algebra, applied mathematics, graph theory and number theory, as well as lunar theory, optics, and other areas of physics. Euler also introduced several national conventions in mathematics. He was the first mathematician to write f of x to denote function. The concept of function that we use today was introduced by him. He also introduced the modern notation for the trigonometric functions. The letter E for the base of the natural logarithm, also known as Euler's number, and the Greek letter for summation, and the letter I to denote the imaginary unit of summation. His main book is Introduction and Analysis of the Infinite. So, here is the analysis of Euler's work. He discovered ways to express various logarithmic functions using power series, and he successfully defined logarithms for negative and complex numbers. He also defined the exponential functions for complex numbers and discovered its relation to trigonometric functions. The next is Euler's formula. For a real number x, Euler's formula states that the complex exponential functions satisfy. So let's move on to Euler's number theory. He contributed significantly to the theory of perfect numbers, which had fascinated mathematicians since Euclid. His prime number theorems and the law of quadratic reciprocity are regarded as fundamental theorems of number theory. Next is geometry. Euler showed that in any triangle, the orthocenter, circumcenter, centroid, and the 9-point center are collinear. And because of that, the line which connects the points above is called the Euler line. In many nations around the world, the 19th century was a golden age of prosperity and new ideas. From the Gilded Age in the United States to La Belle Epoque in France, nations all around the world were in their own golden age. Luckily for mathematicians at the time, this would also be a time with an increase of new ideas and concepts.
Many mathematical practices we learn and use today date back to the 19th century, when there was a huge increase in new mathematical theories and ideas. Though this boom in ideas spreads throughout Europe, French and British mathematicians are responsible for a good portion of these new ideas. Yet, mathematics grows so much during that any account must be selected. Nonetheless, some broad features stand out. The growth of mathematics as a profession was accompanied by the sharpening division between mathematics and the physical sciences, and contact between the two subjects that takes place today across a dear professional boundary. One result of these separations has been that mathematics, no longer able to rely on a scientific import for its validity, developed markedly higher standard of living.
From the early to mid-19th century, new mathematical concepts and ideas flourished in England. Some of the people involved include Wolff, the founder of Boolean algebra and Boolean operators. Next is Babbage, who created an early model of calculator that used cards method. And Picard, who developed symbolic algebra. And last is Venn, who introduced the Venn diagram. Small fact: an unnamed British mathematician in the 19th century expressed pi to the 707th place. Unfortunately for him, only the first 527 numbers were correct. France contributions. The new period of concepts and ideas in France was often separated into three main periods. Each named was after an influential mathematician: Lagrange, Legendre, and Laplace. Other influential mathematicians are Galois, who made fundamental discoveries in theories of polynomial equations. Next, Fourier, who made contributions to a meaning of a function's domain and range and trigonometric functions. Lastly, Argand. According to him, complex number can be represented on geometric diagrams and manipulated using vectors and trigonometry.
Other influential mathematician, Gauss, started development of hyperbolic geometry and theories in the occurrence of prime numbers. Continued development on hyperbolic geometry and developed the first step towards Einstein's theory of relativity. Riemann developed elliptic geometry, founded the zeta function, and tried to mathematically prove the book of Genesis.